Now, today I'm going to be sharing with you a live testing or a real-time testing of autonomous vehicle. Somewhere in China, in Shenzhen, an autonomous vehicle drives alongside with humans. This year, I'm going to be, exposing you guys to a whole lot of applications in computer science. So sit back, relax.
Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
This is a summary of what we have learned so far. Autonomous AI is one of the most crucial applications of artificial intelligence, indeed computer science. Additionally, it can be described as autonomous AI data center on wheels. Furthermore, this is practically depicted as AI processing on real time with sensors feeding and processing in split seconds. Nevertheless, it also faces one of the greatest computing challenges with the most impact. In addition, autonomous AI is one of the largest industries in the world with over 9 trillion miles driven annually. Besides, NVIDIA has recently developed an architecture that is scalable. Ampere architecture, according to Huang, is a system model now integrated into NVIDIA Drive for the purpose of scalability, efficiency, and computational performance. This will now make windshielded or screen cars to be transformed quickly to robo taxis. Here's the NVIDIA Drive with Orin and Ampere as described by Jensen. Now you can see that the ADAS windshield end cap is the predecessor to the L2 Plus autopilot tops. And of course, eventually, this advances to applications in the robo taxis. Okay, so another very important aspect that we should understand in this presentation is that these autonomous driving platforms have a sort of sequence of events. You have the sensing platform, you have the perception of, the perception stage, then of course the mapping stage, then the planning stage, and then eventually the driving, which of course culminates in the fully autonomous self-driving vehicle platform. Now, it is also very important to state here that cars, passenger cars, taxis, trucks, shuttles, delivery buses will eventually be affected respectively, in the future with this sort of algorithm or this sort of innovation. Now, the background image you're seeing here depicts how integrated computer vision software sees and analyzes real-time images on the road with precision of obstacle collision avoidance, image recognition detection, and classification respectively. These all work together to, have a very reliable and flawless autonomous vehicle system. And not forgetting that the boarding boxes you're seeing here is 2D. You know, the 2D is still in operation, but there's in the future we're going to see more of the 3D, and then a correlation between the two-dimensional and the three-dimensional boarding boxes that aids the computer vision algorithm. Okay, so now I like the aspect of the period when Jensen was talking about, data center on wheels. This is very true because autonomous vehicles, they have, with the sensors they have and with other, data trapping devices, the cameras, and so much more, it gives a sort of leverage to understanding real-time environments on the move. Okay, now this concept that I've drawn is just to summarize, actively summarize how autonomous vehicles are built, with respect to computational algorithms. You have the data collection, all right. There are already open source based research platforms, for researchers and programmers to build their understanding and advance their understanding and the application of autonomous or self-driving vehicles. You have the Lift Level 5 perception, you have the Kitty dataset, you have the new scenes, you have the leader datasets, and the cityscapes. There are also so many, but I think these five or thereabout are about the major ones that are on the internet. Now, from here, you can now start training models through training, of course, testing and validating them from the data collected. Then from there, you can actually advance to the simulation, the actual driving simulation, where just like what the GCC 2020 presented that we've just seen, the simulation where the drivers are in their homes and then they are, assisting in, simulating or variating the real world through, software and the likes. Now, then, eventually, you now have the real-time autonomous driving, which, of course, is the physical world itself. Okay, like what I also described during the presentation. Then the last aspect is the real-time deployment. Okay, after it is tested, and it is deployed in the autonomous vehicle. So the real-time deployment is when the users now take over and start using it. And of course, research goes on because as these things are being used by humans, there is definitely going to be much more space for development. In conclusion, I want to make some very important facts known. You see, autonomous vehicles might be already perhaps in real-time testing in the United States, like parts of the United States, then of course China, maybe Germany, Japan, and maybe a few others. But in places like Africa, when I have these discussions with some academics and certain people, I tend to get this challenge that what does or how does autonomous driving or autonomous vehicles, re- become relevant to the context of the African environment? Uh, Let me tell you all something. The very first thing that you should know is that these advances are being done to save or salvage human lives in the future. Electric vehicles are going to reduce fossil fuel and the pollution of the environment. Already we are seeing the impact of climate change world over. There are snowstorms in the United States and in Europe. There is flooding in Africa, like Nigeria and a host of other places in the world, all because of the depletion of the ozone layer. So, electric vehicles are going to could or stand as a middle tier that is going to cut probably the future of saving or completely destroying the world. Okay, every technology might have its own flaws, but there is much more advantage to autonomous vehicles than the disadvantages. Okay, we should do that. And I've also mentioned that the relevance of computer science is interdisciplinary. Okay, we should stop thinking that computer science or computer applications is just about web design, jQuery, JDs, JavaScript, and likes. It goes beyond these peripherals of just web operations. There's so many multifaceted applications to computer science. Part of my future work is going to involve deep learning and image processing with computer vision. Okay, now still in line with how relevant autonomous vehicles will be for our world, particularly Africa. I also get this challenge or this question from people that, take for instance Nigeria. They still a whole lot of, like, almost 99% of vehicles on the road are fossil driven, and they are still manually being driven. So they keep asking that, how does this thing relate to the Nigerian or the African context? All right, now during the presentation, you recall that the presenter of that conference, the keynote presenter, Jin Singh, the CEO of NDA, he mentioned or referred to something that has to do with scalability. Scalability is an extension. You extend to improve, and once you scale up, or once a resource is scalable, that means it can be extended. Modifications can be done to it. You don't need to necessarily reinvent the wheels. All right, Africa can tap into these innovations and these advances through transfer learning, and also scale up, be able to scale up and meet up with the rest of the world as these advances are taking place.
Hi there, I'm Dana, the driverless vehicle from DEEPROUTE.AI.
Okay, you can see now that there is a sort of voice over that is trying to enlighten the viewers about the vehicle. I guess this should be an artificial intelligence, sort of digital AI, digital assistant AI. Actually, it's part of the program that is embedded in autonomous vehicles for assistance, for driver assistance.
Today is August 1st, the first day that the intelligent connected vehicle.
You can see that solid state leader. That leader, the leader is a main framework, that allows, complete coordination of the sensors and the feeding of real-time environment data for processing by the intelligent operating system.
Vehicles regulation of Shenzhen Special Economic Zone comes into force. I heard this is the.
These are cameras. These things you're seeing here are cameras. The tiny bit of stuff. And most of these autonomous vehicles have some sort of numerous cameras back and forth, for the foreground, the posterior, the anterior, the side, and the likes, just to enable the computer vision algorithm to effectively drive without any issues.
First regulation of its kind in China. It's also my first day on duty. Get on board and buckle up for an immersive.
Now you can see the screen there. The screen in the middle there. It shows. It's part of the software that allows the bonding. These are 3D bonded boxes that allows the system, the autonomous vehicle, to actually precisely drive, with situational awareness. The situational awareness, is sort of, enabled and practically becomes a real-time application, such that this mobility utility becomes well established.
Experience of my driving skills. the light turns green, I will turn around. My U-turn was pretty good, huh? Wow, it's getting crowded ahead with many vehicles and pedestrians, but I'm not worried at all. My system has accumulated many corner cases in daily robotaxi operations in CBD areas, so the algorithm is always improving and validating. It's super experienced handling these scenarios. What do we have here? A traffic jam. Looks like I need to navigate through e-scooters and trolleys, but I only have a single lane to work with and double solid lines on the left. I will follow slowly and pass when it's safe. It's green light, but many pedestrians and cyclists are disobeying the traffic rules. I need to stop to guarantee their safety. Be polite and never block the road.
You can see how it is effectively taking, excuse me 1 minute. Okay, so let's carry on. Now what you're seeing is what I actually mentioned in the last video. We were talking of image recognition, okay, and detection, as well as classification. Then we're also seeing obstacle and collision avoidance, okay. This operating system, the AV system that allows this autonomous, driverless car, is so, this is a very perfect algorithm that has been written to bond, bonding boxes. These 3D bonding boxes are so perfect because, they are better than the point cloud. The point cloud is more Cartesian, it represents dots as 3D, interoperably like that. But the more effective one is the bonding boxes that the leader system uses, which is of course computer vision based and is much more accurate.
Another green light, but this intersection also has e-scooters recklessly cutting through. My driving principle? Be attentive and cautious at all times. A trolley is in my way. I'll change to the left lane. Whoa, I guess the man behind me got a bit impatient. I'll stop and let him go first. If you were driving, would you go first or let him go first? Autonomous driving involves a lot of negotiation with surrounding vehicles, and it's not a zero-sum game.
Yeah, that's true. The surrounding, and that is where the perception takes place. The software that actually, the aspect of the software that does this is the perception. The perception recognizes, allows the computer vision algorithms to be written, with high precision and then accuracy to detect and understand what is going on in the immediate environment. And this actually makes autonomous driving and vehicles very, very intuitive.
Instead, it requires both safety and efficiency. I see a strange object coming in my direction. Well, thanks to my deep learning skills, I can classify its type.
Yeah, you heard that. The deep learning, which of course is the aspect of artificial intelligence, allows classification. Classification more how the best or the easiest way to explain or say what classification is that splitting into categories. That's just a simple meaning of classification, and deep learning actually does that. as well as machine learning algorithms.
In cases like this, my perception system can recognize the irregular object, its speed and trajectory. My planning and control system then makes real-time decisions. On the left there's an oncoming vehicle, while another vehicle is parked on the right, leaving a narrow space for me to pass. As a veteran, I know how to pass slowly and safely. These two guys must be surprised by this driverless car and my human-like driving skills, but you're used to it by now, right?
What allows the human-like characteristics of this operating system is that it's been trained. It's been trained over several hours of data. Like I said previously in the previous videos, that they are open source data sets that have actually been released to enable researchers, programmers alike, enthusiasts to come together and improve the accuracy of autonomous vehicles. Okay, the previous training that has produced a testing aspect and the validation set of data, and eventually a model allows the vehicle to implement seamless driving without accidental issues. There's still a whole lot of things to be done in autonomous vehicles. It is not has not gotten to the 100% perfect stage, but I think with this sort of testing, we're inching very close to it.
Oh my, a cleaning guy walked straight from the sidewalk onto the road.
Now you can see that cleaning guy is referring to. The cleaning guy is referring to is, is being bonded. This is a 3D bonding box that has, analyzed the pixelates positions. So the interpretation the autonomous vehicle brings out of this is that it recognizes that this is a human being and it needs to stop.
My algorithm predicts he might continue walking to the middle of the road, so I slow down and ensure he's safe. Another busy intersection. The car on my right seems to be in a hurry and jumps straight in front of me. Lucky for me, my system is responsive and brakes immediately, and drive after him. A bicyclist is spotted ahead on the right, but it's static and I can continue driving. No need to slow down or stop for her.
If you observe it, you see that that image you're seeing in the middle of the screen, just beside the driving the wheel, it's a sort of system that sees in three-dimensional axis. Let's say X, Y, Z. So the aerial view, you can call the aerial view the Y-axis. Okay, where you go from top to bottom, or you can say vertical axis. Then you now have the, of course, the x-axis, which is just goes from left to right. Okay, so all the objects within that plane is recognized. Then you have the z that goes from the middle below. So you draw a circle around x, y, z, you have a three-dimensional view, and that's exactly what is seen. So the system is working. This vehicle is working with satellite imaging and its own operating system data that it has, that is updating alongside with the embedded model.
I'm making a left turn. Oh, an e-scooter is coming this way. I'm worried he might continue at that fast speed and dash in front of me. I better be cautious and slow down. Now he's stopped. I can pass the crosswalk now. A bus on the right is merging into my lane, but I didn't expect that other car to barge in. Thank goodness my perception system noticed the car at its speed, so I can slow down instead of a hard...
Now, perception systems, like I said earlier, they are the fulcrum, more like the basis of a perfect autonomous driving system. The perception is what allows image recognition and detection, classification, objects, and collision avoidance.
Hard brake, ensuring safety and comfort. I'm now on the interchange and merging into the right lane. I see one vehicle signaling to merge into my lane. I slow down to allow him to merge first, then drive forward. Another e-scooter cutting through the crosswalk. He might be busy delivering takeout. Life's not easy. I'll let him go first. This car is driving quite slow. Since there's no other traffic on my left, it's safe for me to go around. Let's get off the interchange. Did you see how smoothly I merge into the main road? Many cars are lining up to turn around in the left lane. The taxi on my right wants to cut in and make a U-turn. Since he blocked my way, I'll slow down and let him go first. A taxi is here to pick up passengers, but it's part of my lane. With a slight left tweak of the steering wheel, I can pass with ease. I'm going to make a right turn. It's always polite to give way to these pedestrians and scooters, right?
Of course.
Does this e-scooter know it's going the wrong way? I'll stop so he can get to the sidewalk safely. Okay. That's enough for today. How'd I do? Coming up, I'll conduct road tests across different districts in Shenzhen to further improve my algorithm and comfort for future passengers. I hope my performance today gives you a deeper understanding of autonomous vehicle technology. We provided robotaxi services, logistics transfer, and help during the pandemic, and this new policy and legal support lays the foundation for the commercialization of autonomous driving. You will see me deeply involved in the future of daily lives. Stay tuned and see you next time.
Now, this is what would I say, or rather, how would we rather describe this? The future, like what Jensen said in the 2020 GTC conference, everything that moves eventually will become autonomous. And this includes what we're seeing right now. We're looking at cars being autonomous and virtually perhaps trucks, lorries, and so many things out there. So the future of programming, software engineering is big. If you have chosen to learn programming, whether you're learning from the PHP, SQL, or you're learning from the Java axis, or you're learning from the Python axis, or any of like React natives and the like, these things, this knowledge will eventually help you to become, very relevant in tomorrow's world.
I hope you enjoyed that. Now, please, if you're on YouTube and you're watching this video and you're a science student, I need you to subscribe to this channel. Are you in Nigeria? Are you in Kenya? Are you in South Africa? Are you in Ghana? Are you in Sierra Leone, West Africa, North Africa, or any part of Africa? Subscribe to this channel and please give it a thumbs up and help us grow. Till next time, cheers and all the best.